this demonstration, we are demonstrating friction. We have static friction in the Petri dish, and we have a string that is tied to the Petri dish and a cup that is down here. In the Petri dish, I have 10 chips. And what I'm going to show you that with static friction, which is the strongest of all frictions, means that there is no motion. What I'm going to do is I'm going to take one chip from the Petri dish and place one chip into the cup that is attached to the string, which is applying force. But as you can see, as I add mass to the cup, it is not enough force to overcome the static friction of the Petri dish with 9 chips in them. As I take one chip from here, and I have 8 chips in the Petri dish and 2 chips in the cup, I am still unable to overcome the static friction of the Petri dish by gravity's pull on the cup and the string. If I take one more chip from the Petri dish and I place it in the cup, I am now at a ratio of 7 chips in the Petri dish and 3 in the cup, and it is still not enough mass pulling down on the cup to overcome the static friction. I can remove one more chip from the Petri dish and place it in the cup, so my ratio now is 6 in the Petri dish and 4 in the cup, and when I let go of the cup, I now have enough mass in the cup. Gravity's force is pulling down to overcome the static friction to make sliding friction. In our experiments, we were coming up with ways to either increase or decrease the static friction in between the surfaces of the Petri dish and the desk. For example, if I take a paper towel, got it wet, placed it underneath the Petri dish, this would now be my independent variable to increase the friction between the Petri dish and the surface of the desk. I still have 6 chips in the Petri dish and 4 in the cup. I will now take one out of the Petri dish and place it into the cup. Now my ratio is dish to cup, 5 to 5. And when I let go of the cup, there's still not enough mass in here for gravity's pull to overcome the static friction. I can take one more out of the Petri dish and place it into the cup. And when I let that go, my ratio now is Petri dish to cup. It is 4 to 6. So without having the paper towel, it was 6 in here and 4 in the cup for a ratio of 6 to 4. Now I am at 4 to 6 and I still do not have motion. I haven't overcome that static friction. So I can go 7 in the cup and 3 in the Petri dish, and when I do that, I overcome the static friction. So in this experiment, my independent variable was the material that I placed between the surface of the Petri dish and the surface of the lab station. My dependent variable was the ratio of chips in the cup to the chips in the Petri dish.